right, so here we are with number 6. This is where we start doing all these transformations, and they're all jumbled in here together, okay? This very first one gives us the function f of x, and it says write a new function, g of x, for this transformation. This transformation is a reflection over y equals 0. So our new function is g of x equals, this is a 7 raised to the x power. We want to reflect it over y equals 0. Well, when I reflect over the y equals 0 line, I know that means I have to change the sign out front. So our answer is negative 7 raised to the x power. Nothing changed except for that sign in the very front. For my next one, I want to translate 1 unit down. So I have g of x equals 2 raised to the x power, and to translate 1 unit down, it's just a minus 1 out on the end. That's just the rules we learned. To do vertical translations, we just work with the numbers in the very back. To do left and right movement, we work up here in the parentheses in the exponent. And to do reflections, we end up putting negative signs or positive signs, depending on if they're negative already. We flip signs out front or up top, depending on what kind of reflection we want. Okay? Number 8, is one of those horizontal translations. So we want to move 3 units to the right, which means somewhere up here in the exponent, I'm having to do that transformation. Okay? My new equation is g of x equals, I had 5 raised to the x power, and I want to move it 3 units to the right. So I know that up here in the exponent, I'm doing something with that 3 to the right. And it's the opposite of what you think. When you think 3 to the right, you think plus 3. But in the parentheses or in the exponent, it's the opposite of what you think, so it should be x minus 3. Number 9 says write a new function. So we're still doing g of x is our new function. And this time we want to reflect over x equals 0. Well, when I reflect over x equals 0, I'm changing the sign of that letter x in the exponent or in the parentheses. So what I have is negative 5. That negative 5 stays the same. We don't flip that sign. That's why that's in there, guys, is to trick you. Is to get people to accidentally flip this negative in the front. We would change the negative in the front if we were going over y equals 0, but we're going over x equals 0. So we changed the sign in the top. It was negative. It is now positive. That's our new equation. Remember, if you're ever not sure how this works, you can check these, okay? And it's multiple choice. So here's our starting equation. Negative 5 raised to the negative x power. Let's just look at this one in the calculator just to check it. Negative 5 raised to the negative x power. I think our answer is negative 5 raised to the positive x power. Negative 5 raised to the positive. That's what I think the answer is, because I think I know that rule. But I'm not sure, so I'm going to check it. I want this to reflect over the vertical line, x equals 0. So on my graph, I want this to reflect over this horizontal line right here in the middle. And it did. Here's our original graph. And if we were to take it and fold it over to the other side, this blue line, its long line, would fold over to here. And this curve part would fold to right here. So if we took it and made a mirror image of it across this vertical axis, this vertical line, x equals 0, if I want the mirror image, I got it, okay? So this turned out to be the correct thing. Number 10, we're doing a vertical translation 5 units down. So our new function is g of x equals 6 raised to the x power. And when we do down and up with vertical translations, we work with these numbers out back, and there was already a number there. Okay, so I know a lot of people are going to look and say, oh, 5 units down, that means minus 5. That's wrong, okay, because there was already a 3 there. So this minus 5 actually affects that 3. There was a plus 3, and now we minus 5. Well, these two things are like terms, so we can combine them. Our final answer should be g of x equals 6x minus 2. Again, remember, there's a website, okay? It's known as Desmos, and it's a great way to graph these things on your Chromebook. So if you just Google Desmos, it's going to be the first thing that pops up. It's a great way to graph these things on a Chromebook. So just because you don't have these graph calculators at home doesn't mean you can't check this work for homework. We have our 6x, 6 raised to the x power minus 2. If we plug that into Desmos or into our calculator, we'll see that it takes this original f of x function and moves it down 5 units, because we did minus 5 out back. Okay? Write a new function for the reflection over the horizontal line, y equals 0. So when I see that, I know that means I'm working with this sign out front. If I'm reflecting over y equals 0, I'm reflecting changing the sign out front. So I should have g of x equals, this was negative 3, that means now it's positive 3 raised to the x power. The x didn't change because we reflected over y equals 0. Okay? Number 12 is tricky because two things happen. We want to go up 6 and right 1. Take them one step at a time. We have g of x, that's our new function, equals negative 2 times 3x. And now we want to go up 6. Well, up 6 means we got to go plus 6 out here on the back. But we're also going right 1, and I know right 1 has to happen up here with the exponent. Right 1 is the opposite of what you think. So it's minus 1. Anything up in the exponent or in parentheses is the opposite of what you think. So there we got this one covered. Right 1 is covered. Now we need to address the up 6. So we do plus 6. Now they both will be covered. We're good to go. Okay? Number 13. We want to just say in words what transformation was made from f of x to get g of x. So we have to see what changed. I see this negative 7 showed up, and that's the only thing that changed between f of x and g of x. That means we went down 7 units. Same thing with 14, but two things changed. This minus 7 now popped up in the exponent, and the plus 1 popped up outside. Isn't that tricky? It was minus 7 over here, and that meant down 7. But over here, this minus 7 in the exponent, that means right 7, because it's the opposite of what you would think. So we went right 7 and up 1 units, because that plus 1 on the end means we're going up 1. All right? Number 15, given that f of x equals 7 raised to the x power, two things changed. This sign changed out front, and this negative 3 changed out front. The sign change out front is going to reflect us over something. Well, when it's out front, I know it reflected over y equals 0. That out back means that minus 3 at the very end means we went down 3. And now I just want to have a little stop and talk about this because I actually made a mistake when I was creating this problem. Okay? Really, this reflection, this negative sign out front, would affect both of these numbers. So technically, this actually, if you check in the calculator, should make it go up 3, I do believe. That's just a problem that's a mistake I made writing the problem. It will be correct on the test. But as far as you know, for the scope of this class, I would expect you to notice both of these changes and document them both. Okay?